Hey guys, welcome back. We're day 30 now. Balancing. All examples. All right. Now, my recommendation is for you to do these on your own. Then come back while I'm going through it and just check. And then if it doesn't work out, you make a mistake, then listen to me. Right? But you ain't gonna hurt my feelings. Just go do it without me. Go through it. See if you can get it all done. Do it, practice without me guiding you, and hopefully this really helps you get this as a foundation down. All right, so we're gonna start balancing. First thing we're gonna do is start with the most complicated formula first, which is right here, chromium 3 oxide. Now, if you look, even number, I can make that even real easy, but odd number of oxygens, even number of oxygens, right? So because that's a 2 and that's a 3, I'm going to have to fix that. All right? So I'm actually going to start with oxygen this time instead of starting with the chromium. If I start with the oxygens, I need to put a 2 here and a 3 here, right? So now I have 6 oxygens on both sides. Well, that means I need a 4 in front of chromium. And then we're good to go. All right? And that's just a synthesis reaction. The next one is a single replacement reaction. And if you look, I have 2 coppers on the left, 1 on the right, put a 2, and 1 sulfur, 2 oxygens, 2 oxygens. That's it. Now, technically speaking, there's a 1 there, a 1 there, and a 1 there. So if I were to ever ask you, what's the sum of all the coefficients, the answer for number 2 is not 2. It would be 5, right? 1, 1, 2, 1. Next one. The most complicated formula is probably this one. Methylbenzene or toluene. You don't need to know the name of that. All right, I have 7 carbons. 7 carbons. Right? So I would need to put, right here, I would need to put 7. Hydrogens. We have 8 hydrogens. So I can put a 4 here. I have 7 times 2, 14, and 4, which would be 18. 18 oxygens, so I would put a 9 there. And then we're good. Now, that's a combustion reaction. Number 4 is a double replacement. Bust out the highlighter. I got carbonate here. And carbonate. And then we have nitrate and nitrate. All right. And so with these double replacements reactions, I always start with the salt on the right side. Right, one of the salts. And so if you look, I have 2 potassiums, 1 potassium, 2. Carbonate's good. Now I have 2 nitrates, 2 nitrate. Yep, that's it. That's all it is, right? And so I would balance those polyatomic ions by themselves if possible. The next one's neutralization. And again, we have phosphate, blue here, phosphate, and phosphate. Now, technically, hydroxide doesn't survive. All right? It makes water. And so this is right, acid, base, salt, water. So if we look at that, I always start with the salt. 3 potassiums, 1 potassium, put a 3 there. 1 phosphate, we're good. I have 3 oxygens, so I need to put a 3 there. Then we check our hydrogens, make sure they work. I got 3 plus 3 is 6. 3 times 2 is 6. We're good. So that is balancing. That's the easy part of balancing. What's the hard part of balancing? Right here. Phosphoric acid, well, fortunately, that's right above us. H3PO4. And I'm actually going to give myself some more space here. Magnesium hydroxide. If you need to do this, magnesium, Mg2+, hydroxide, OH-. Write that out. So I get MgOH2, right? Okay, now this is an AQ. This is a solid because it tells me salt. What's the salt? Well, it's going to be magnesium phosphate, right? And I know phosphate is PO43 minus, so I get Mg3PO42 and water, H2O. And if you need to, go ahead. I got phosphate again. If you want to do that, feel free. So now, if I look at my salt, magnesium phosphate, I got 3 in front of magnesium and 2 phosphates, so I need a 2 there. So then if I look, I'm going to probably need how many oxygens? 6 oxygens, and that gives me a total of 6 and 6, 12 hydrogens. We're good. That's it. That's all it takes. Again, practice is going to be lots of practice. Okay? Ammonium nitrate. Again, if we need, make sure you know these polyatomics. NH4 plus, NO3 minus, N2, O2, H2O. All right? We need to be very good at coming up with these polyatomic ions and these formulas. It is a fundamental. So ammonium nitrate is NH4NO3 solid. Decomposes into N2 gas, O2 gas, and H2O gas. All right, I look at the ends. Ends are good. I look at the H's. H's are not good. You put 2 here. Right, so now I have 2, 4 oxygens and 3 oxygens. Ooh. So my oxygens here are not good, right? Because I have 3 here and I have 4 on the right. The only way to get more on the left is to put a 2. But that means I need to put a 2 here in front of N2 now. And that means I also need to have 4 in front of H2O. So now we count the oxygens. 4 nitrogens, yes. 8, yes. So I have 6 oxygens here. 2 plus 4, 6. Done. Worked out. All right. Solid calcium phosphide. Again, writing out the formulas. Ca2 plus phosphide, P3 minus, H2O, Ca2 plus, OH minus. Phosphine is pH3. That's just a common name of the molecule. So, calcium phosphide is Ca3P2 solid plus water H2O liquid going to CaOH2, which is an AQ, and pH3G. All right, so now I'm going to start with calcium phosphide. 3 calcium, so I need a 3 here. 2 phosphoruses, I need a 2 there. All right, so 3 calciums is where I looked at to get that. The 2 phosphoruses for that. All right, now, oxygen. 6. Then you put a 6 in front of water. And then double check the hydrogens. 6 times 2 is 12. 3 times 2 is 6. And 6. So 12. Works out. All right. Moving right along, aluminum hydroxide. I'm going to do it this way. Oh, not aluminum. Aluminum's H. Hello. Al and OH. And then sulfuric acid, sulfate. So aluminum sulfate and water, R's. Great. And so we have now AlOH3 solid plus H2. I need two H pluses for my SO4. AQ to give me Al2 SO4 3 and H2O. This looks like an acid base. It's written base acid, but acid base salt water. So if I'm going to have an acid base salt water, I'm going to start with the salt. 2 aluminum. So I need to put a 2 in front of aluminum. I have 3 sulfates. So I need to put a 3 in front of sulfuric acid. Right? And now I'm not worried about the sulfate because that's already balanced. So I go 6 oxygens, and so I need to put a 6 in front of H2O. And that gives me 12 hydrogens here, which is giving me 6 and 6, 12 hydrogens there. Excellent. All right, so silver nitrate. Silver is Ag plus nitrate, NO3 minus, Na plus carbonate, CO3 2 minus. All right. So AgNO3. That's in solution. AQ plus Na2CO3 AQ. Silver carbonate precipitate. Ag2CO3 solid. And guess what? The sodium nitrate are still there, so we have to continue them. They're just not solid. All right, now do our polyatomic ions work out? Yes, they do. So I got nitrate here and nitrate there. And I have carbonate here and carbonate there. All right. So I got 1 silver and 2 silvers. I need to put a 2 here for a silver nitrate. And now my silvers are good. How's nitrate? Nitrate, I need a 2 in front of sodium nitrate. So the nitrates are good. Sodium now is good and carbonate's good. And that's it. And even if you're struggling writing the formulas down, go till we get the formulas, then hit pause me, and try to balance it. Make sure you're balancing correctly. So ethylamine reacts with oxygen gas, O2, form carbon dioxide, CO2, water, H2O, nitrogen gas, N2. All right, we got it. So C2, H5NH2, G, plus O2, G, going to CO2, G, plus H2O. It doesn't tell you, right? You can put down a G, you can put down an L. Probably not an S. It does not tell you, though, in this case, what's it going to be, right? So if you put a gas down, I'm happy. You put a liquid down, I'm happy. Probably not going to make ice, most likely, if that makes sense. All right? And then N2, which is a gas. So like in our classroom, in the classrooms we teach in, we buy the periodic tables from Fisher Scientific that are color-coded. And so the elements, you know their state at room temperature. So nitrogen would always be a G at room temperature because it's red in our periodic table. So is oxygen, right? Whereas, mercury and bromine are liquids, they're blue. All the solids are black. Right? So I do expect you guys to kind of know that in the seated classroom. Online, you guys, we'll see. We'll make sure that it works out. All right, so we got to balance it before we go to sulfur trioxide. So what do we got here? Carbon. We're going to start with carbon. Make carbon good. Nitrogen, not good. All right, I need to put a 2 here, don't we? All right, because I have N2 here. I just have one N, so I had to double that, which means that becomes a 4. All right, so how's H? I got 7 H's, don't we? I have 14 H's, 5, 7, 14. So I need to put, yeah, that's a 7 here. And that gives me 8 and 7 is 15 oxygens. Right? Is this 15? 8 and 7, 15. So the best thing to do is write 15 halves here. And then times by 2, times by 2, times by 2, times by 2. That's the best way to do this. All right? And so that's what I'm going to do. Write 15 here. 4, 8, 14, and 2. Now we need to double check. Got to double check. All right, so we have 4 times 2 is the same thing as 8. I have 7 times 4, which is 28. 14 times 2, 28. 4 nitrogen, 4 nitrogen. Oxygen, 30 here. 8 times 2 is 16. 14 times and 14. 16 plus 14 is 30. We're good. Whew. That was a tough one. All right. That was a tough one, but that's okay. You're getting it. 12. Sulfur dioxide. Trioxide. So SO3. Reacts with water, H2O. Sulfuric acid. So sulfate. Sulfate is SO4 2 minus, so I need 2 H's. All right, let's do SO3 gas. H2O, we know that's probably a liquid. Could be a gas, but and then H2SO4 probably in water because we got water there. Let's see. Sulfur 1 and 1, good. 3 oxygen, 4 oxygen, 4 oxygen, good. 2 H's, 2 H's. This one is balanced. That one is balanced. That does happen. Believe it or not. All right. Boron sulfide. All right, reaction with water from boric acid and hydrogen sulfide gas. Hydrogen sulfide is just H2S, just like H2O. So we got this one. B2S3 solid reacts with water, H2O liquid, to make H3BO3, AQ because it's dissolved, and H2S gas. All right, going through. Hopefully you're getting more comfortable with this now. I got 2 borons on the left side, so we got 2 borons now on the right side. Got 3 sulfurs on the left side, so it means I need a 3 on the right side. And if I look, I got oxygens. I got 3 times 6 oxygens on the right in the product side, so it means I need to have 6 on the left. That gives me 12 hydrogens, and it looks like I have 12 hydrogens on the right. That looks good. Phosphine. Again, phosphine. pH 3. O2. H2O. Tetraphosphorus decoxide. That A, I put the A in there for y'all, but it's decoxide. And so that would be P4O10, right? So let's try it. pH3G plus O2G to give us H2O G and P4O10S. All right, let's look. P, I probably need a 4 here. That looks like I need to start that way. And then hydrogen, I have 4 times 3 is 12. Put 6 and 2 is 12. All right, so then on the right-hand side, I got 6 plus 10, 16. If I put it 8 times 2, 16, I think we're good. All right. Only a few more. Mercury 2 nitrate. That would be Hg2 plus nitrate, NO3 minus, heated. Mercury 2 oxide, O2 minus. Nitrogen dioxide is NO2. Oxygen is O2. All right. Got it. Hg NO3. That's a horrible 3. That's better. 2. Heated. Gives us HgO solid plus NO2 gas and O2 gas. All right. So it looks like nitrogen's not good. So I'm going to have to put a 2 here. And that gives me good there. Mercury's good. Oxygen, I have 6 on the left. I have 4, 6, 7 on the right. So I got to put a 2 here, which means that becomes a 4. This becomes a 2. What happens? So let's check. 2 mercury, good. 4 nitrogen, we're good. 2 times 3 is 6 times 2 is 12 oxygens. I have 2 plus 8 is 10, and 2 more is 12. Good. All right. So now we got copper metal is just Cu. Sulfuric acid, H2SO4. Copper 2 is Cu2 plus, sulfates SO4 2 minus, SO2, and H2O. I think we got this one. Let's do it. Copper metal, Cu solid, H2SO4, AQ, and it's hot, right? CuSO4. And SO2 gas and H2O liquid. All right. How's copper? Copper looks fantastic. How is sulfate? Oh, guess what we can't do here? All the sulfur comes from this sulfate right here. And there's 2, some are sulfate, but some sulfur dioxide. So I cannot balance sulfate by itself. Can't happen. All right. That being said, I need a 2. Since I have 1 sulfur on the left, 2 on the right, I need to put a 2 here. Ooh, how's that do? Well, sulfur's good. Oxygen. I have 8 oxygens on the left here. So we got 4 times 2, 8 oxygen. So I guess 4, 6, 7. I could put a 2 right there. That was 8. How does that affect hydrogen? Hydrogen's perfect now. 4 and 4. Beautiful. So now we're balanced. All right, hydrogen sulfide, H2S. So iron 3, Fe3 plus hydroxide OH minus. The resultant products sulfide, S2 minus, and water is water. All right, so H2S, G. FeOH3 solid, Fe2S3 solid, and H2O gas. That's what it looks like. All right. Let's look at iron. Iron needs a 2 in front of iron 3 hydroxide. Sulfur needs a 3 in front of hydrogen sulfide. That leaves me with oxygen. Oxygen needs, looks like a 6. Does that work out for us? 6 and 6, 12, yep. That works out. Balanced. All right, phosphorus trichloride, PCl3. Water, phosphoric acid, and hydrochloric acid. All right. PCl3. Oh, I forgot the triangle up there. PCl3 in its liquid. Reaction form water, which is a liquid. It forms phosphorus acid, H3PO3, Q, and hydrochloric acid, HCl. All right. Well, our P's are good. Our Cl, I need a 3 in front of Cl here. And then it looks like I need a 3 in front of water. So I have 6. Yeah, that works out great. Doing good. All right. I think we only got 2 more. You guys are doing good. Almost done. So zinc metal. Zn. Sulfuric acid, H2SO4. Hydrogen gas, H2, and zinc sulfate. Sulfate's SO4, 2 minus, and zinc is 2 plus. All right, so Zn solid plus H2SO4, AQ going to H2 gas plus ZnSO4. All right, yes. All right, zinc's good. Sulfate, I think that's balanced. Is that balanced to you guys? I think that's just balanced. All right, that one gets a nice big old check, right? One zinc, H2, H2, SO4, SO4. Beautiful. Last one. Yay, you made it. Potassium chlorate. Potassium chloride, O2. All right. Oh. So KClO3 solid, and that's heated. KCl solid, and O2 gas. Well, I can see right away, hopefully you notice this, you have 2 oxygen and 3 oxygen. That's not going to fly. So I need to put a 3 here and a 2 there. So now we have 6 oxygen, and I probably just need to put a 2 there, and we're good. So that's balancing. Hopefully you are a pro now. If you have any questions, don't hesitate to reach out to me. Otherwise, have a great day, and take care. We'll see you next time, guys. Bye.